Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about ULA's Vulcan rocket. So let's dive deep into it. So what exactly is this puppy? Well, this is Vulcan Centaur two-stage to orbit rocket. Now this is a heavy lift class series rocket. Now what does heavy lift mean? The classification is a bit sloppy, but generally anything you start to cross 10 tons to low Earth orbit, you start to get into that territory. So by this logic, Starship is classified as super heavy lift series rocket. So it's a heavy lift rocket that is made for USA. And critical aspect here is that Vulcan is the first stage that has BE4 engine, Blue Engine 4, that is from Blue Origin. That puppy uses methane and oxygen, liquid methane and oxygen. So that's why the flames are blue. And it has Centaur upper stage. That's why the Vulcan Centaur, when they will say about the Centaur, is the upper stage, which has RL41C engine. The C could be replaced with H or X series in the future, which has liquid hydrogen and liquid oxygen. Now, the critical aspect of that is that specific impulse of this puppy is huge. It's 454 seconds, which is awesome. Now, it does have some serious benefit because once you get into the orbit, accelerating from orbital velocity to even higher velocity, the specific impulse becomes compulsory requirement. So hydrogen still is king in that department. Then to make sure you get off the pad, you can use just the naked core itself, or you can get graphite epoxy mortars SRBs. There are specific SRBs that are developed for this. So it has a lot of range, as in a lot of variability. So at the basic nude configuration, it can send around 10 tons to low Earth orbit. And if you just go YOLO on it, as in like put 6 SRBs, this puppy can do 47 tons to low Earth orbit. Basically, it can go from okay rocket to like, I got this rocket. And now that is okay, but here's the interesting part. When you talk about geostationary orbit insertion, this is where this puppy shines. So it goes from 3 ton, which itself is like damn, to 15.3 ton, which is holy damn. There are very few rockets as of now, removing Starship, that can claim this as like damn, like 15 tons to geostationary orbit time. That's the benefit of this, having liquid, basically hydrogen. And not only that, because ULA is an old company, it does have some understanding of the government requirements and all that, and they were rich when they were designing this rocket. They designed the payload fairing to be very spacious, very voluptuous. So it has enough capacity that you can actually put some big puppies in there without compressing or folding them too much, which is desirable for many spy missions, many satellite requirements, all that jazz. So would there will be more rocket that have even bigger than this? Yes. Not anyone that is in active use right now. So this is very significant. So what about the launch? Now launch was flawless, as in like it was so different from all other things, because we are used to watching launch missions from new startup companies and SpaceX trials and all that jazz. But here it was like we launched it, it went, the end. There was nothing. There was just like, okay, we launched it, it went, the end. It's very, very simple. It just did its job. Now, however, while it did had a Peregrine mission, now Peregrine mission is a series of missions that NASA wants to do before they want to send a human back to the moon. The reason for that is they want to collect far more data. So because this time they want to stay there for long term. So for that reason, they need a lot more hands on the ground, so to say. So for that reason, they wanted to do some missions. But if they run the numbers, it turns out if NASA did that, USA will go bankrupt. So they contracted that part out to basically private companies. In this case, Astrobotics got that contract. So Astrobotics built this puppy, NASA was contracting this. However, this puppy malfunctioned. The moment it was detached, they noticed something was wrong. The best analysis is that when it tried to do basically burn and basically orientation and all that, something failed and propellant leaked out. So first there was like, it was not orienting properly, so solar panels were not on the sun side. Consequence, battery was continuously going down and it was reaching a point where it would be just dead because it won't have solar energy. But they fixed it. Then turns out like, yeah, it's even bigger issue. So it is going to the moon, it's just not going to land on the moon. So that part sucked, but rocket just worked. That's why like it was so weird. It was like, oh, there is this company that just made a rocket, it just launched the rocket, done. It was so uneventful. Very interesting. Now first real launch being a success, that's like damn. So that's significant. Blue Engine 4, as in BE4, it's all go, and that also gives Blue Origin as a corporation hope for New Glenn. Now there is a bit of conflict of interest because Blue Origin must make all the engines that is required by ULA first. Only then they can go to basically new Glen development. It's in the contract. But again, so far the launch was very flawless. It did what it's supposed to do, how it's supposed to do it, and it also had solid booster. So you can be damn sure that solid booster separation algorithm is also working, and the fact that it also had reignition, which also worked very perfectly. So everything just worked. Now, why the heck ULA is building this? Well, you have to understand this. ULA is a rough child, basically. The two parents that made it didn't want to make this puppy, so to say. So, what you have to understand is the early days, there was US government spy contracts and commercial contracts and NASA contracts. Now, NASA contract was taken care by Space Shuttle. Spy contract, you had to do biddings and all that. Just now, here's the deal. That bidding was so illustrious that companies went all in with just that. Consequence, their budgets became lol. So no commercial company could even touch any US launch provider to like, hey, can you put our commercial satellite into orbit? And the answer was like, lol, no. So slowly everybody went to Russia, then they went to ESA, then they went to China, then they went to India, and this was an issue where they were like, yeah, if we do not fix this, we're gonna have a very serious issue. So to fix that, there were lawsuits were also happening, and in that they figured out Boeing was like doing some naughty things. So they were like, okay, if both of you keep fighting, USA is gonna lose. So detach your launch division. So basically both of them detach the launch division. That's why U is there in the ULA, United Launcher. Basically those two detached unit got married and they made United Launcher. And the benefit of this approach was that this is one company that's gonna buy rockets from Boeing and Lockheed. Now, you would think this will be enough, but unfortunately this is America, so they had to pay this puppy $1 billion annually. It's almost like how basically Arianespace is blackmailing European agency. Was like, dude, if you do not pay us, we'll stop the development. Same thing was there. It won't be cost effective if they did not get that subsidy. However, with all that rough life, they had one issue. One of the rocket that does work was hyper expensive, and another rocket relied on a basically Russian engine. So consequence was like, yeah, they did not had any actual long term future. Like, this is what we are, this is what we're gonna do. And every time they did try to develop something, either Boeing locked it or Lockheed Martin locked it. So issue was, they did not had actual future. And then the Fire Nation attacked. SpaceX came to reality and they started eating up everyone launches. And the sole reason why they were like so confident that nothing bad is going to happen, it was the military contract. And USA fought a lawsuit to get the ability to at least bid and have some reasonable chance of actually winning it, which they won. Then they put a military satellite and then they put more of them. Slowly, government was like, no more subsidies for you. I'm out, and that became an issue. And everybody right now, SpaceX is in a position where all the road leads to SpaceX. ESA launch missions, SpaceX. ISRO launch mission, SpaceX. USA launch mission, SpaceX. Every Tom, Dick and Harry, SpaceX, including Bangladesh mission, SpaceX. So this became a very serious issue. So they needed something to stay in the game. This two puppy were like just outdated and the money was running out, and they were like, yeah, we have to fix something. Otherwise, yeah, no. So they were fighting for their survival. So Vulcan had to work. Now, it did work. So what does it mean? This means market competition is back. Now, you have to understand this current aspect of USA is that USA got bitch slapped by Space Shuttle. Space Shuttle not only failed, it also took people's life and it crippled USA's space wing. They lost the ability to send people to the space, so to say. So the solution was very clear from day one. For next generation of crafts that they're going to build, they will never have one point of failure. They will must have multiple points of options, basically multiple options. So they should not have like, oops, done, we're done. That should not happen. So that's why having a second company that is using a rocket that has engine that is built in let's say 2010 technology rather than built in 1970, that was like, shut up, take money. And that's how they call it, high technology engines. I'm like, I'd never understood what does high technology engine means. It simply means it's designed with a recent understanding of our developments, basically. Every other design is like, you look into it, like you really look into it, it's like, okay, this engine is from Soviet Union. It's not even from Russia, it's Soviet Union. Many engines are like that. Or like, American engines that are like ancient engines. So high technology engines means like somebody threw everything out and it's like, okay, let's start from fresh. So having two companies that can deliver that puppy is desirable. So they got that. And this also limits SpaceX to, they cannot do price creep, which Russia did, where they're like, okay, in the early days, they're like, just give us this much money, we're going to launch your astronauts to space, brother, no problem. And then they slowly, it's like, brother, little bit more money, brother, little bit more. And like USA could not do anything. So they have learned it the hard way, that DA shall always have, market competition. Like right now, how, some large company instantaneously destroys, by pricing themselves into negative. They literally run loss just so they can poof all the competitor out, and then they jack up the price because you can't do anything now. So USA has learned this, that's why they are paying so many other players to become a competitor to SpaceX. They have learned it the hard way. That shall not have one point of failure. Now, is there a USP to it? Is it something that only this can do? Yes, that's also there. If you need high velocity, meaning any velocity after orbital velocity, this puppy is like, I got you. And if you need something large, like let's say a space telescope that you do not want to fold like a origami, you're like, dude, one or two folding we good. We just do not want to like fold it into it. Good. And heavy, because there's a 13 ton to geostationary orbit. I guarantee you there are more than enough spy satellite designers that are orgasming right now. They're like, dude, shut up, take money. We can look into people's soul from geostationary if we have 13 tons in or there. So some serious unique capabilities also there. It's not just like, okay, a rocket that is not bankrupting us. It's like, okay, it has some unique selling point. And Blue Origin can also now ramp up this, because it's one thing to say I have an engine, another thing to I have an engine that went to orbit and got everything done. So that also becomes a new wing for them, new inspiration. Once you have production tested engines, mass producing them is not that difficult. So they can go there. And SpaceX free human launching is now possible, in principle at least. So you have to understand, space, once they America, once they lost their wings, SpaceX built Crew Dragon, and Crew Dragon is working, which is awesome. Everything is fine, everything is great, except this one thing. There is only one company that can do that, and Boeing should have been the lover child of it, but they are so behind schedule that it's not even funny anymore. But there should always be two options. This is one option, that's awesome, but what about second option? Boeing Starliner, if it ever comes to be, at least it has a rocket for it. So that's one good option. Second, which is more likely to happen, is Dream Chaser. Dream Chaser is slowly chipping away at it, and now it's getting more money from NASA and everybody else. So there is a possibility in future that Vulcan and Dream Chaser working together can send astronauts to ISS or whatever upcoming space station without having the issue as like all road leads to SpaceX. That's a very good thing. From America's point of view, Space Force point of view, they're like, we good, we are doing good, we are going in good place. Even if you are like, hey, isn't SpaceX gonna launch your rocket stuff for $100 million and they are charging 120, here's the deal. The moment you stop saving that 20 million, it's like, I'm just gonna pay 100. Over time, this competition will go away, and then they're gonna charge 150. What the hell are you gonna do at that point? Nothing. So people have learned it the hard way. Da shall always have competition. So this is a very good outcome. So what can we expect in the future? Now, right now, if you are not very well versed in business world, you must think like, oh, once this puppy starts to actually work, as in Starship, all other competition are gone. Well, yes and no. Now, here's the deal. If Elon Musk's weed numbers that he's quoting for this rocket launch is true, which is not, yeah, that's not happening. Why? Because this is very similar to Airbus A380, which was an amazing plane, ludicrously large capacity of people, and they built it, it flew, it is in service, but it Airbus did not made enough, basically did not sold enough of it, that they are cancelling the line. That's why I always am saying physics, engineering, economics. This rocket does not make economical sense. Yeah, it's big, it's bold, it's awesome and all that, but it's like, does it make sense? How many missions are there that needs that sort of capability? The answer is only one on a regular basis, which is Starlink itself. And imagine a future where they actually do this, okay? And by that time, there would be fifth or sixth iteration of Starlink satellites. Those satellites won't have like short lifespan of the modern ones. They will have long lifespan. So there could be easily a very good time where they have launched enough of the Starlink satellites that they may only need to replenish, quote unquote, once or twice a year. Then what? There are only few missions that requires this. And Mars mission, but sounds good. It's like, who's gonna pay for it? Sounds great, but who's gonna pay for it? So there is a serious potential of this becoming a good rocket, but to be like, yeah, we don't actually have customers for it. Exactly same thing happened with Airbus A380. So it's too big for way too many missions, and it still needs time. Be mindful. Right now, if you need to launch this, this is far away. It's not ready yet. It needs some time to cook. So Vulcan has some potential upgrade also planned. So this has a potential weakness, and Vulcan again, the rocket is ancient design. Engines are good. The design, rocket design philosophy is ancient, but it does have some potential options that can allow it to thrive in future. Because here's the deal: if they currently kept working on their current cadence, is they're not going to survive the next generation of rocket manufacturers. For example, Rocket Lab, and other branches that are also working, they will also destroy this. So smart reuse is their first tool. The idea is the most expensive part of a rocket is rocket engine. The fuel tank, while it is expensive, it does have like a fancy lithium aluminum alloy, CNC milled it and then rolled it and then friction welded, all that. Yeah, it's expensive, but it's chump change compared to engines. But what if you have a boom device and you just boom the lower section of the rocket, which has the engine and all the plumbings, everything? You will design in such a way that everything that is of value is in the lower section, and you just have a basically inflatable heat shield, and you just splash down it into the ocean. So that's the current idea. Now, will this ever work? I do not know. Now, if I were a betting man, I would not put too much stock in this sort of approach. However, they do also have another option, which again, this is why I said like ULA had a rough childhood, is that advanced cryogenic evolved stage. Now, this has some serious advantages. If you remove this, this becomes one of the only options where you have the ability to have liquid hydrogen and liquid oxygen in space for long duration. So the idea is right now from launch, a timer starts. Okay, you started the timer, it starts to do launch. Okay, everything. Here's the deal. If you do not spend all the fuel of second stage, which is liquid hydrogen, it's going to boil off. So they have few hours of window of opportunity, as they say. But they want to take that window of opportunity and stretch that puppy to weeks, where they could even do refueling or do some tugging operations. So how would you do that? Well, you need energy for that. Well, you have hydrogen, you have oxygen, meaning you can just run a combustion engine on it, and you can get rotational power, which can be utilized for other things like hydraulic pressurization and running a cryocoolers and all that jazz. You can do more than enough that all the little boil off can remain little before it becomes too much boiler, because you are actively cooling it. So it has some serious potential. Like they actually built the damn thing. They were like very seriously doing this, but politics got into it, and they were like, oh, if this works, SLS will not have any mission. I'm like, dude, SLS does not have any future. Stop forcing it out. In 2 or 3 launches, even Senate will be like, yeah, we can't actually just sign away $2 or $3 billion per launch. So this, I will put more money on this puppy rather than a smart one, but this is genuinely unique, and it's again, it's threading the needle of where SpaceX can't go. So that's a very wise thing. So that's the future option of basically what ULA can do. What's the option of basically Starship? However, there is another option. If SpaceX is smart, which most likely they are, once this is done, like once they have launched it and it's done and it's doing all the Starlink operation, they will switch to basically rebuilding a better Falcon 9. Because be mindful, Falcon 9 was built by a company that was poor. So that's why it's too skinny. It's like it has to use normal roads. ULA does not have to worry about it. ULA is like, dude, we have barge, we can afford it. And you can look into Starship. Starship is built by SpaceX that is now rich. So what the first thing they do? Wide. So imagine a same system, a Boca Chica itself, and they're like, hey, what if we build a new Falcon 9, quote unquote, or its replacement, which uses a Raptor engine, so that will simplify their manufacturing process. And they're like, okay, we just have one engine production line, which is really good for efficiency and cost. They're like, okay, we got that. And they put, let's say, 5 engine, 6 engine, whatever have you, or maybe 9 engine if they really want to go. With current wisdom, they have learned a lot. Like Falcon 9, it had to go through so many iterations. They are like on block 5, and grand total list of innovations from day 1 to now is like bonkersly high. Now imagine all that innovation from day 1. So Raptor engines, that will solve so many problems. It will also allow them to much higher efficient reuse also. And with big diameter, they can go, oh, you have 5 meter, 6 meter, baby. They can go big diameter, plus they can improve that one weakness that it has, like improve the basically more high energy insertion. Methane does give you higher specific impulse, and because you have more thrust, and you can have like such a large capacity into low Earth orbit, where it's like, hey, if our satellite can't do this, like our rocket can't do this, just put a kick stage. That's how Rocket Lab can send things to almost moon. It's like, yeah, we have a third stage, kick stage, which they call it. So kick stage is much more economical compared to solid boosters. It's like everything remains the same. You just put a kick stage if you need it. If you do not need it, nothing changes. You do not have to change the redesign the core and have boom boom devices going boom boom. So that's a really good thing. So improve reusability. They no longer even have to worry about T-tap, where they're like, oh, sometime T-tap ran out. That has happened. But imagine going from that to like, hey, electrical system. Imagine hydraulic failure to like electrical actuation. So there's so much learning that SpaceX has that the moment this is done, let's say 5 years from now, this is done, like this is done, it's good, go. They can easily make a better Falcon 9 with their modern technology. And then they're like, Vulcan, I was hearing you were trying to do something. Then they can bitch slap that. And it will not have the issue of Airbus A380. It's like, it's too big, it's too bunkus. It's like, it will be cost effective also. So the future is going to be interesting. So this was my presentation on ULA's Vulcan Center current launch. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.